Can you hear me? Perfect. I hope everyone's doing fine after last night. Welcome to my talk, which is about Headless Hydra, or live coding on improbable devices. You see two of these improbable devices here. I will use some of these during the talk. One improbable device is sitting in this box. It's a really nice case made by a friend, but it's a Raspberry Pi 3B. Inside, it's a Raspberry Pi, and it's connected with this wire to the composite video input of the TV. And this other improbable device is on my screen. I will do a screen capture. No, anyway, it's an old phone. Maybe I will not be able to show it because I was trying to broadcast it from my phone. I'm going to do and start with a little bit of storytelling, and then I will transition into a little bit of a meditation with a live demo sandwiched in between. So it all started with this shop was run by a guy in Berlin called Andrei. He was selling musical effect pedals, and he had these two screens, old TVs, in the shop window. And they were, in fact, run by a little Raspberry Pi and two wires really put together. And when I saw this, he had a couple of events there. I was like, oh, this is really cool, but really, Raspberry Pi even has a shader? And he had a setup where he had the code base on GitHub, and you could sell pull requests, and you could add to the script that was running on the screen. And it was not as simple as that, and I never touched the Raspberry Pi up to that point, but I was like, I gotta do this, I gotta get my sketch on there. So I went on this mad quest to understand how a Raspberry Pi works, how shaders work in a Raspberry Pi. And I basically spent the weekend getting it to work, and I like to keep things minimal and small. So I wanted to make this work without a windowing system. I wanted to start something from the command line on a Raspberry Pi with an operating system that has no X11, no GNOME, no nothing, and come to a point where I can execute a shader and output it through composite video to the screen. And this is the moment at our studio in Prachtsaal when late on a Saturday evening, while a show was going on in the other half of the venue, I got it to work and I got the fabulous, famous triangle on screen. And eventually I continued this and managed to create a script, which I would show on this phone, but that's not going to work now, which is a little dancing animation of Lissajous curves in 3D. And just to give you a little bit of a peek inside how this works, you have to go through so many system layers with these three-letter names that I never ever heard about, like DRM and EGL and GBM, just to get to the ugly part, which is OpenGL. And I managed to half live code, half research, somehow figure out how this works, and put it all in a CBP file, which I just called horrors CBP. So it basically has two functions, which it exports, that are important, actually three. Init horrors, get to the screen, flash the current OpenGL buffer onto the screen, and then clean up and exit. And it looks like this. And really, this is horrible. And I don't know what's going on, but I had it. And great, I never want to look at this again. So back to my talk. This, just for 2 weeks before the shop unfortunately closed down, it was there in the shop window. And the source code for this is on Codeberg. I'm calling it Shanad, as in shader native. Feel free to check it out. But there was another piece of inspiration, and that has to do with solar punk and permacomputing. There's a group, it's just two people in Berlin who are running this little web server, which is available at compost.party. And what you're seeing here is the web server. It's an old Xiaomi phone with a solar panel, and it's in the roof in the attic of an old building in Berlin. And at one point, I even got an account to this, and I'm really proud of that. And I'm like, oh, I want to try that myself. And for months, I kept pestering people to give me their old Android phone, which they don't need anymore. And someone graciously gifted me this. This is a phone from 2017. And you can install an OS called Postmarket OS on it. So you can see it very well. There's a little bit of content at the top. This is a login screen. Like you could, no, there's no keyboard now. This is also a headless device, no windowing system. It's just a terminal, a console. I'm going to, well, without being able to project it, I'm just going to show you that you can connect to it. I'm in the phone now. And run a program, and it's playing the little animation on the screen. And I was like, wow, this is awesome. This is so much fun. Okay, back to my talk. It also runs a website. Right now it's connected, so you can go to lexi.monster and you can load this up. That's coming from this very phone. And then I thought, so basically that's how I came to all this. Like, oh, this is actually a phone. It runs Linux. I did this for the Raspberry Pi. Can I also make it work for the phone? And after another evening, yes, I did make it for the phone, and then it's playing this nice animation. Very, very good. And there was a third source of inspiration on this journey, which is, more broadly speaking, the experience of live coding. And this is a photo from an event a few years ago, also at our venue at Prachtzaal. This is a person called Dan Goralik, and I unfortunately forgot who the other person were. They were jamming, they were doing live coded music and acoustic music. And the visuals in the back, you can actually see it at the top, that actually comes from a platform or a little tool to create this, which is called Hydra. It's a browser-based environment created by Olivia Jack. I did not create that. You can write very concise JavaScript functions, which are inspired by analog video synthesizers. So they replicate a lot of the things that analog synthesizers can do. And then all of these things came together. And then I thought, this is a project for me. Let's recreate Hydra. But then without a browser, without JavaScript, so that it can run directly from a command line on like a low-end device like this. And this basically shows what is going on here. So I open 2 SSH sessions. In one session, I start essentially what is Hydra, that is the box at the bottom, which has a render loop. So it puts the shaders on the screen. We've just seen that. Then it has this module, which is the actual Hydra, which parses some inputs. So you can type text, and it will understand what that is supposed to do. And it's a shader. It's essentially a WebGL shader generator. So it reproduces the shader generating functionality of the original Hydra and puts that on the screen on the GPU. It also has a little file system watcher, which watches a particular file. And whenever that file changes, that contains the source, it reparses the source, updates the shaders, and put them on the screen. And in order to mess with that file, you have to log in through another SSH session and start any editor you want. That will eventually, when you press a shortcut, overwrite this file, which is the live.txt. I created some creature comforts for Emacs, because that's an editor that is very extensible. And what you're seeing here on that screen is essentially that. So I'm logged in through 2 SSH sessions, and this one is running the player. It just said, oh, hello, I'm running at this resolution, and that's the file I'm watching. And here's another SSH session into this Raspberry Pi, which is this little editor. And if I change something here and press the magic shortcut to update the sketch, then it'll do something different. I'm actually not very good at live coding, so it's so much easier for me to create a sketch by subtracting it than by adding it, but you can see it happens real time. Okay. And then I sort of thought, oh, now let me talk about some of the nerdy details here, and then I'm going to add the final step. Source code is right here, so it's also in an open source repository. The original Hydra has an AGPL license. Mine correspondingly also has an AGPL license. I wrote this in Go, because that's just a very sweet spot in terms of languages for me. It's very low level still, pretty low level. You can keep it small, but it's I can work fast in it. I can work much faster in it than in a language like C++ or Rust. That's just me. It has very few dependencies. Initially in my description, I said no dependencies, but that's really not true. So to put the shaders on the screen, it uses these low-level system calls. It does use a library, a Go library for wrapping up the GLSL part. For parsing Hydra, the actual language, I use the parser generator language, which is pretty well supported, called Antler. So you write like a normal form grammar, and it will create code that parses using that grammar. And the output is a 7 megabyte executable on these devices. And just for fun, I looked up. Firefox is 500, actually that's megabyte, that's not gigabyte. Chrome is 1.3 gigabytes, and you can use whatever editor you want, but I used Emacs. And some more details. So there are some differences from the original OG Hydra. So the line at the top would be how you would write something in OG Hydra, and the line at the bottom is how you write it in Headless. So the original is a JavaScript library. Essentially defines a lot of functions like OSC and rotate and blend are all parts of the Hydra library. It contains a lot of predefined GLSL functions that basically correspond to these, what is an oscillator, what is a rotation. It's the runtime is browser-based, so it's the browser that does the rendering, and it's in a built-in editor library called CodeMirror is used to do the on-screen editing. In Headless Hydra, it's a Go library, so not a JavaScript. I copied the exact same GLSL functions. The runtime, so the thing that puts the animation on screen, is in Go, and then you use the external editor. For technical reasons, then you have a parameter that changes frame by frame. The JavaScript one needs to use these lambda functions, but because I control everything, I realized I don't need the lambda functions, so I could make it a little bit simpler. I made it a little bit simpler in terms of syntax, how to deal with sources and with the outputs. So yeah, that's the very technical part. And yeah, a little bit of demo. Well, actually, I already just did the demo. So I switched to the terminal and I showed you, I have these two sessions, and that's how we put, okay, I mixed up my own order. But then, and this is what I was doing since actually I submitted this talk, I realized it's a little bit awkward that I need to have this terminal open where I can edit the stuff in Emacs, and it's on my screen. And then I kind of have to look at what it is doing on the actual screen. And either I'm looking at it or the audience, or like, I should somehow get the editor on the screen here. And how do I do that? What I ended up doing is, so let's just have one SSH session. And I start my Headless Hydra tool, which I call HH Player. It has all the things that it had before, but it also launches as a child process the command line editor, so Emacs, and pretends to be a terminal emulator. So all of the key presses that I do over SSH, it just sends on to Emacs. And then what Emacs barfs back at you is text to write on the screen and some control sequences, which are like, move the cursor one line to the top, change the color to blue, things like that. So by trial and error, I looked up what are all the control sequences that Emacs uses. So I'm doing all the drawing on myself onto a bitmap. And then I can put this bitmap on top of the actual, I put this bitmap on a texture, and the render loop can overlay this texture onto the output of whatever the shaders are doing. But of course, and here's the thing, if I have a texture, I should be able to use that as a source in the Hydra patch itself, right? So that is actually, without further ado, what you're seeing on the screen now. So that's why you have this wavy effect, which I just turned on at the very beginning. Maybe some of you were watching. I can take the editor as a texture and apply some modulations to it, and then just blend it in with all the rest, which is the images that I use in the background. So this is, this is the overview, what you're actually seeing right now. Exactly. Sorry, this is where I am. Doing this, I did a couple of other dependencies. So, if it runs on those devices, it also runs on my laptop. So this window is also Headless Hydra. I use this GLFW, which is like a little window framework, and Go. You just create a window for you, and you can display shaders in it. I use a little library to create a terminal emulator to make Emacs believe that it's running in a terminal, and some other library to help parsing the control sequences. All right. And just to illustrate like what's going on with all this shady, with all this wavy stuff here. This is one of the things that Hydra can do. Render noise. It's just like a noise at a certain. I think it's actual Perlin noise. I switch back to the overlay mode, so no floating now. This just like naively blends in the editor, and then I can say, oh, let's just have a solid color background, reddish. Let's capture the editor, so this bitmap, into source one, and then for my actual output, let's take the background and layer a scaled and modulated version of the editor, modulated by this noise that I'm showing now, on top of the background. And this is what's happening now. And you can still see that I have the overlay, plus then now I have the sketch going on, which also contains a little bit of the editor, so I can turn that off. And now I just have the waving effect, and I'm ready to do a talk, which I just did. And now I kind of want to go a bit into the meditation, because at one point I did need to stop and think like, what am I doing? Why am I doing this? What sense does it all make? And besides, it's a lot of fun, and I'm a geek, and geeks have fun this way, but this is part of a broader context. So one of the things that I'm thinking about here is sustainability. So from one angle, this is permacomputing, what to do with these older, particularly the phone, how to give them, how to fight design obsolescence and keep on using this stuff without producing new stuff. So this is actually two angles, how to reduce the footprint of whatever I'm using so it can also still continue to run, so the footprint of my tool, so it can continue to run on lower end hardware, and how to extend the lifespan of that hardware. But there's also this other thought here, which I just made this connection 2 days ago. Someone once talked also in this permacomputing setting about how can you make a particular piece of software last longer. And they had this angle. Unfortunately, I cannot quote who it was. I forgot who this thought comes from. But it is, well, make it small enough that when the environment changes, when the languages change, when the platform changes, you can, or when your ideas about it change, you can just rewrite the whole thing. And you can rewrite it again and recreate it again. And Hydra is exactly that sort of a bite-sized thing. With a few weeks of afternoon work, I was able to create Hydra. And then with some more work, I was able to do this like terminal hack over it. So that's just a thought to put out here. There's another angle. I think in a way, for some value of subversive, I think this is very subversive. So computation basically comes from a background where it was a tool of centralized control and surveillance. And then we had this little paradise where it was a tool of individual self-expression. And I think we all kind of share this feeling that now the zeitgeist is that it's really, again, becoming more of a tool of centralized surveillance. And every act, I think, that you do to use it for creative self-expression on your end-user devices is sort of fighting that trend. And I see, all of this as part of that bigger context. And then finally, and I want this to be the closing thought, this is also very specific, and this is the crowd. When I talk about shaders, most of you know what this is going on, what I'm talking about. But this is still very niche, very special. Like, what can we do to make this joy of creative self-expression through coding accessible to more and more people? And that was the main reason why initially, all of this was like live coding shaders directly. But like, who live codes shaders? Already by thinking like, let's bring in Hydra, which is already established and is accessible to a lot more people. People from less of a computery background use it to perform live with it. I thought I could bring this a little bit closer to a broader audience. And I think that is something that we, who are very much in the weeds with all of this can keep thinking about how can we make this, all of this, what we are doing, more accessible to more and more people. Help them fight the system. Thank you.
Turn it on.
Hello? Oh, awesome. Yeah, amazing talk. I actually work in post marketing, so it's really cool to see cool things on our phone.
Thank you.
We have a quick minute or two for questions. I've got some questions here.
Sorry. Thank you for your project. My project is like node editor for the same Hydra engine, but in the web. So my problem is placing several instances of Hydra, the several sketches on the canvas, for example, and positioning them because I want to show the previews in the node, in every node. And so after 10 instances of Hydra, for example, it goes very slow. So maybe you have some idea or something of how to achieve that, or just think about it. But anyway, it's awesome, and I will probably try to integrate it in my project.
Yep. Thank you. Yeah, it's a challenge. So, and these little GPUs are very limiting. So in every pixel, it's a fragment shader. You can do up to a handful of sine or geometric functions, and then it becomes slow. So yeah, it's a challenge.
Awesome. I think we might have time for one more question while the changeover happens. Is there another question? Okay.
Oh, yeah, you just kind of answered it, but yeah, I was recently looking at running like my Colab projects on on a Raspberry Pi, and so I was wondering like what the performance is and how complex of a shader can you make it, at which resolution, that kind of stuff.
I don't have like the exact answers for you. You have to trial and error. You have to think of, you have a small envelope to work inside, yeah. All right.
Awesome. Well, thank you.
Thank you.